Welcome to our classroom. Welcome to the classroom. Welcome to the classroom. The segments where I bring the classroom out into the field.
Welcome to the classroom. Today I'm standing at the base of a small retaining wall. It's only about a meter high at the back and a half meter at the front. It is more of an aesthetic retaining wall to make this slope appear very nice, but it also serves a function to resist the movement, the mass of that soil there that will resist that movement down slope. You can see that the slope would continue out and onto the sidewalk. So probably when they wanted to construct the sidewalk in this road or this building, they wanted to have the proper width, in fact, in order that the slope didn't interfere with the location of the sidewalk. You could move the sidewalk to the other side, but a lot of the time we have sidewalks on both sides, so we need to have that space. And one way to create that space is to create a vertical retaining wall to resist the mass movement down slope. We call this movement mass wasting. There's many different types of mass wasting. You can check it out in the lectures for the course. There are flows, debris flows, or mass flows, that mass being the soil or the rock or a combination of the debris mixed in with the natural earth materials like trees and foliage and so on. There are slides. These are larger movement of material down the slope that can be in rock, that can be in soil as well. There are different styles of slides. That's where the material is actually sliding on a planar or a circular surface. That is the failure surface. That material is moving on. And then we have falls or topples, typically more in rock. The blocks of rock are falling down the hill due to gravity or toppling over. So this wall actually is an example of toppling because it's starting to lean out. The top is over top of, in a vertical line, the bottom, and it's starting to lean out and want to tilt over. And that's a great indicator of a very slow moving mass wasting event. And in this case, it's probably a slide. We may have a surface under there that is moving, or that this debris is moving on. There are other indicators for this slide, such as the linearity of this wall. They would likely have constructed this wall pretty straight. And you can see in the picture here, a lot of waves in the wall. And you can also see some cracks forming right here where the brickwork is separating apart. And you can see some of these blocks, they're starting to tilt. These are all indicators that this wall is starting to move compared to the way it was constructed. And the actual trees themselves, some of these trees were probably here prior to the construction of this wall. And there may have been either movement at that time during the construction, or there was movement on this slope even prior to that. And you can see some of the trees that have a very slight curve. It's not a good indicator in this slope. The wall is a better indicator of the mass movement down the slope. But you can see places where the whole forest, all the trees, have this curve in them. We call it a drunken forest, and this is a great indicator of slow movement down the slope. The trees, they want to grow vertically, and as the slope moves underneath the tree where it's rooted into the ground, then it's moving, and then the tree has to grow up and reorient itself so it remains vertical. But, you know, in terms of movement, a slow-moving landslide gives us time to try to deal with the situation. Fast-moving landslides are harder to deal with, and we may not know when the major failure is going to occur. But here we have some indicators, and we can come in and we can actually do some geotechnical engineering to design this retaining wall or rehabilitate this retaining wall, and we can actually calculate the mass of the soil, that is the driving force, and then determine the weight of the wall that would be the resisting force to hold back the slope. So you can learn more about that in another Welcome to the Classroom video, where we'll go into detail on how to calculate the driving and resisting forces. Thanks for watching. Like and subscribe.